As a web episode here, we're going to be doing M2 Power with special guests Tom Evans and Chapman on the show today, currently. Okay. So we're going to start off labelling the forces on the diagram, and then we're going to do some maximum speeds and powers.
Beautiful.
Hi everybody, today we're going to be doing some power. Here we have a diagram of a 1200 kilogram block vehicle moving up an inclined slope of 5 degrees. So firstly, we've been given the task of labelling the diagram with all the forces. So up here we have an F force. This is the driving force, the tractive force up. And what we need to find, obviously, is the reaction force here. And the way we're going to find that is we know it's an equilibrium, the only force acting downwards, exactly opposite, is going to be the same. And it is going to be 1200 G sine 5, because we have a 5 degree slope. And we know this angle here is also going to be 5 degrees. So that's a simple one there, 1200 G sine 5. And that will also be the same up here, the reactive force. We know reaction force is the same as this gravitational force here, acting down. That's all in equilibrium. Alright, so now we've labelled our diagram, we need to know this force here, the driving force, the tractive force. We've been given in the question that the block is moving at 15 metres per second, and that means there is no, it's a constant, no acceleration. Constant acceleration of 0. And so we know that F is then equal to this force plus the driving force of 1200 G sine 5. This should be cos 5 is at 1200 G sine 5. As we know, 5 degree incline, sine is always up the way of movement, and cos is across, perpendicular to the way of motion. And then we need to add this force, equilibrium, so we know this force is the same as this one, so we need to plus the 1960 newtons, and then all of that added together should give us an answer of 2,984, rounded up to 2,985 newtons, and that is our driving force.
What's going to happen here is we're going to find out the power that is actually being produced in order to make this force here. Okay, so power equals force times velocity. Okay, so that's just going to be 15 times by the tractive force, 2,985, and that's going to equal 44,774 watts actually of power. Now the question also says this car has a maximum power output of 60 kilowatts. And what that tells us is that 60 kilowatts divided by velocity, watts divided by the maximum speed, is going to equal the maximum force here pulling upwards. And so what that means is that 1,960 newtons plus the gravitational force is equal to this maximum force, because P divided by F equals V. So we can know after that that this minus 1,960 newtons minus 1,200 G sine 5 is equal to 0. These two forces cancel out backwards and forwards, and we can rearrange this equation and we'll get 60,000 watts divided by 1,960 plus 1,200 G sine 5, and this should actually equal a speed of 20.1 meters per second is the maximum speed of the car. So